All right, well, good evening. Back to college algebra here. So what I thought I would do with us is take our ready to learn topics here, give us a brief review, and then walk forward and see what's going to happen with the assignment stuff. Okay, so this first one is identifying a function from a relationship, and this is kind of what we talked about last week at the end, was whether or not something has a vertical line point or not. So it's just, did it follow the rules? Okay, did we follow the rules for this? So when we are looking at domains and ranges, like is a relationship a function, right? What we're trying to check is everything in the domain have an assignment, right? Does everything in the domain get used? Okay, everything is being used. And then the second thing is, how many arrows does it have sticking out of it, right? If it has more than one arrow, then it's not a function. Say, and only one assignment per domain element. All right, so what we have here is, this may be a little thinner, as best as I can go. Okay, so there is a relationship of function. Is everything in the domain used up? And do we only have one assignment per domain element? So this first relationship, right? They give us a relationship. Can I get something that's slightly larger here? I want that thickness just a little bit. All right. So we have our domain and our range here. So let's see. We have here's our domain set. We have a tree, a star. We have a chair. We have sky. And we have a desk. All right, here's our domain. And then for our range, the only reason I'm writing this down is just because I want to be able to do a couple of different things here. So we have 4 and 6. So for this particular one, here's the assignments they gave us. Okay, they said tree goes to 4, star goes to 4, chair goes to 6, sky goes to 4, desk goes to 4. So this is fine as a function, right? Everything here has an arrow sticking out of it, and it only has one arrow sticking out of it. So we're good, okay? If they had given, so right now it's a function. If we had done something like this, where I said, well, desk could go to 4 or 6, right? Then this would no longer be a function. Or if I added an extra thing in here and just didn't bother assigning it, then it wouldn't be a function. But as it's written, the way we have it, right? Well, there. Now, as it's written the way we have it, it is a function because everybody has an assignment and it only has one assignment. The fact that the range, right, we could have put more stuff in the range. That's fine. We could have put 2, 4, 6, 8, 10 and only mapped to 2 and 4. That's fine. If we, if all the arrows are sticking into one thing, that's fine. Okay, so that's not what the rules are. The rules are only on the domain. We don't have a lot of rules on the range. Okay, so later on, we're going to be a little bit pickier about this. And when math teachers say range, they mean only the elements that get assigned to something, or only the things that are assigned. But technically, that's not true. The things that are only assigned, that's called the codomain. That's I'll talk about that later. But, so I don't know how much, with the relationship here, right? Sometimes they hide it. They put it in a set builder notation. They put it in set notation here. And what we're looking for here in this last one, we have Z and D, D and B, X and D. What else we got here? And we have B and B. We could make this kind of a shape, right? We could say, well, what's in a domain, right? Our domain set is we have a Z, a D, an X, and a B. And our range set, right, is D and B. Oh, it's just two of them, just D's and B's. So Z goes to D, fine. D goes to B, fine. X goes to D, fine. And B goes to B. And that's what this looks like. So this follows the same rules. So we're just looking to see, in this case, is there any of these, are there any of these ordered pairs that have the first element appearing more than once? If that's true, it's not a function. So as it is, this is a function. Okay. So let's go on and talk about another option here. Come back over here. Vertical line test. This is the nicest thing, right? So it doesn't matter if it has a formula. Okay, it doesn't matter if it has a formula or not. Circles have formulas. Circles fail the vertical line test. So I'm looking at graph one, clearly, right? Not a function. Oh, I can't interact with this stuff. Graph two, with these little dots. One of these, right? At least one of these has a both -1 has two different entries. It's not a function. This one looks like you know, we can't pass a vertical line through more than one thing. Horizontal, sure, but that's not the rule. It's just vertical. This one, okay, number 4. Well, this little filled in dot means that the function actually gets to this point, but this open dot means it actually avoids this spot right here. Okay, it doesn't quite get there. It's an open interval. Okay, it's like a parenthesis in interval notation. So you have closed, right? That's going to be that'll be part of the function. That'll be part of the domain here. But if you look at this, doesn't it go through? I'm like, no, this little circle here does not include this point. So these do not overlap. All right. So this would be a function. Line is a function. And then this guy right here, this is, we could pass it through both the, right, there's a lot of vertical lines that go through here. So it would not be a function. All right. So I'm going to go ahead and click off of that. Oops. Sub-build notation. This is a little bit weird. Okay. So what we want to do is we want to rewrite the set by listing the elements. Okay. So we want S is equal to Z. So this starts at is the set containing. Okay, so when you see this curly bracket thing, which I can't read either, that is the set containing. This bar here, this means such that. Okay, so we want this element, we want S is the set, but we're going to have Z's as elements, okay, such that Z is an integer. Okay, and it's somewhere between -1, and +1. Okay, this is going to be a very boring set here. So we have an equality, right? So -1 is definitely included. 0 is an integer. And then you might be tempted to write 1 in, but it says like up to, but not including 1, right? It's strictly less than 1. So 0.99 will be just fine. 0.999 will be just fine. As long as they're not infinite, we're okay. But there's an integer, so we're not there. So that's the set we have. It's -1 and 0. Okay, that's great. All right, let's do another one. Let's see if they give us one that's harder. Wow, we have a gamut between A and A. Really? All right, let's come up with another one. Let's go with n such that n is natural number. How about we say n is an odd natural number. Okay, so if we wanted to start writing this, we would say s is equal to 1, 3, 5, 7, 9, and then so forth. You want to list enough points so that people actually understand like what's going on. I wouldn't, you know, I'm sure you've seen enough Facebooks where it's like, what's the next element in this sequence? And sometimes it's like, how the heck did you get that? Right, so if I do 1, 2, 4, right, and I ask you what the next one is, and maybe we go with 8, you kind of need this many so you know that I'm doubling each time. All right. All right. But seeing these patterns, sometimes it takes a little bit of practice doing this. But that's what we could do. Okay. So how do I write this? I write this as 2's, I guess. And such that 2 to the n. N is I will say whole number. So I put 1 in there. We'll say a whole number. Tell you what. Okay, and then we will write that down. I'll go into some of this a little bit someday when we need a little bit of a break to discuss all the different kinds of sets there are with numbers. It's always a nice thing to do with math, but it's also one of those things we want to save it for, a day where you're like, oh, we've done like 3 problems, 4 problems, they've all been hard. Let's do something else. Okay. So here we go. We have H and M here. All right. Oh. What am I doing? I don't want to do that. All right, I'm not that good with the laptop still. All right, so let's see what we have. We have -10178. So this is -10178. And the other one was -21258. -21258. Okay, and they want to know what is the intersection. This means elements. These are elements. Are in both H and M. Okay, so which ones do they share? Oh, 1, they share 1. Okay, 2, and then 8. All right. And then this upside right this means union. This means elements that are in either H or M. In either H or M. And I'll say it this way. In math, or means it implies both. Okay. In math, or implies both. In English, it doesn't. All right. So there's a little bit of a difference there, but it's got to be in H or M or both. All right. So -2, -1, 0, 1, 2. And you don't have to list it twice. The fact that we had 1 both times, we only list it once. 2, 5, 7, 8. All right, so it's just everything that's in either of these things. All right. So if you say to a child like, hey, for dinner, you could either have mashed potatoes or Brussels sprouts. And I know all children love Brussels sprouts, so they'll say, yes, I'll take both. That would be fine in math. Okay. If you say to your child, well, you can have ice cream or cake for dessert, usually you mean one or the other, but not both. Okay. But in math, the way that you ask that, both would be an acceptable answer. That's called, or if you want to, in math, if you want to say one or the other or not both, but not both, that symbol is X or. It's exclusive or. It's one or the other or not both. Okay. We don't really go into that in any of the notation in the books, but just in case you were wondering, that is a way to say one or the other, but not both. All right. So yeah, we'll probably go back and revisit this a little bit, maybe tomorrow. And but for now, we'll call it a day for that one. Okay, let's look at some of the other problems that we have. All right. All right. Oops, I don't want to do that. I want this. Okay. So what we want to do here is they're asking us, okay, we're talking about slopes, okay, we're talking about two linear equations and two variables. We're going to be talking about slopes and equations of lines and all of that fun stuff that goes along with it, okay? So with slope, okay, this is just a definition, okay, for our slope. We're going to say that the slope is equal to the change in elevation divided by the change in linear distance. Okay, in high school, in junior high, they often call it's the rise over the run, right? It's the amount you're going up and down divided by the amount you're going from side to side. Okay. In science books, they're going to go ahead and give it to you as the change in y. This would, the upside right triangle is a delta, capital delta. If I could spell delta today, all right, it's capital D. Okay, and it means change. Okay, that's how the science people use it. So we could say change in y over change in x. Okay, so if you have a book from the 1970s, maybe 80s, they're going to do it like this. Okay, so when I'm looking at this problem, right, how much are we going up and down here? Right? We're going up and down 10 feet, and we're going side to side 80 feet. Okay, so that's going to be 10 over 80. Now, normally I would say, hey, it looks like it's going downwards, right? So we'd have a negative 10. We started at like, 10, and we went down to a different value. But the instructions say that we want the absolute value of this, which just means take out the sign, okay? Just means take out the sign. And we just have 10 over 80. They probably don't want that. They probably want 1/8, right, to cancel that out. I don't think they want 0.125. Okay. Oh, write your answer in exact simplified form. Let's see if they take an eighth. Maybe they don't want an eighth. Maybe they do want 0.125. No, they're going to make me check or something. Oh, okay, there we go. Check. All right, you like the fraction. This wasn't so bad. I kind of want to try another one to see. Okay, that's 15 over 20, right? We have 15 up and down for this one, and then 20 across. So this one, right? They said this was 15, this was 20. The up and down part, right? The rise part, that is 15 divided by 20. It is negative, but we're taking an absolute value here. So this is negative 3 times 5 over 4 times 5. Those cancel, and we end up with negative 3/4. I wonder if they'll let me get away with, I'll do this. I know we often have medical people, so we'll put the leading zero in to be proper. By the way, you don't have to. Okay, the people don't. The books don't care if you put this leading zero in or not. All right, let's see if they yell at me for that. Oh, they did not like it. They really want the fraction. Oh, it's also absolute value. That's why they didn't like it. Let's see if they'll take that. Oh, okay, to take the fraction, to take the decimal. All right, very good. So you can plug it in your calculator and you'll be just fine. All right. So let's see here. We have a road sign. Up a hill, we have gives the elevation, gives the slope of the road, the change in elevation per 100 feet. Given a 2.6% grade, write this slope in a simplified fractional form. Okay. All right. So we have a 2.6% grade. So what this is saying is we have 2.6 feet in the up direction, and then it says per, right? Per 100. That's also what this means, is per 100. Okay. So per 100 feet. Okay. This way, horizontal. Okay. So here we have the slope is 2.6 divided by 100. Okay. No, it isn't. That's not going to do that. We don't want that. We want here we do. No, we don't. I want y. Sorry about that. I just had like a little brain freeze there. Okay, we're okay. And then we have to go ahead and simplify this, right? That's probably what we want to do. All right. So write this form in a simplified fraction. It is simplified fraction. What are you doing? Okay. Well, we have to do the decimal place, so let's times 10. Let's times 10. So what we did, that's how we got that. All right. Oh, 26, not 260. I am not having a day at this point. All right. And then, here, watch what you do. Now, this is 26 is 2 times 13. And 1,000 is 2 times 500. So that cancels. We get 13 over 500. Let's see if it takes that as an answer. Oops, no, 138. Come on. Oh, okay, that is what they want. Very good. Let me show you something. Okay. So if you type in 2.6 over 100, right? And then you go to math here, and you see this thing that says fraction? You just hit that, and that'll pop that right back up for you. So it'll automatically turn a decimal into a fraction for you. If this was painful and you don't want to think about this too much, you will have access to a calculator, okay? And that's how you do that. I would urge you to try it this way, to see if you can't get it the fraction this way, because it'll help your number sense. But at the same time, if you're looking at one and you're kind of getting stuck, maybe you're going in the wrong direction, you can type them in this way, and it'll work out. Okay. I always feel a little bit bad about doing that, because when I was in elementary school, we had, you know, doing the math, and the teachers, the nuns would tell us, like, there's never going to be a calculator that's going to do that for you. And I feel so terrible because, you know, I feel like I'm dancing on their grave now because they didn't anticipate all of that. It's a horrible thing, but there we are. Okay. So here we go. We have to figure out, like, determine the slope of the line passing through the given points. All right. So the biggest thing here, okay, we're going to write down a formula in a second here, but sometimes it helps to label these points because the formula that we're going to use, right, is going to say, well, m, that's slope. Okay, that's equal to y2 minus y1 over x2 minus x1. Okay, so it's up to you. It doesn't matter which one you call 2 and which one you call 0.1. Okay, we could have swapped this and it would be just fine. We would get exactly the same answer. Okay, so it doesn't matter which order you put them in, but the important thing is matching the x's and the x's and the y's with the y's. Okay, that's the biggest thing. Most students, that's the mistake they make, is they do these two, right? Where they do the outside ones and then the inside. Like, no, it's got to be the x goes with x, the y goes with y. And if you call this one 2, you got to call that one 2. All right, so we're going to have -4, that's y2, right? y2 says -4 minus y1, -10 over x2, -8 minus -2. All right. And then we have some simplifying to do. And I'd recommend do the simplifications first. Okay. 4 minus a -10. That's -4 plus 10, isn't it? That's -8 minus a negative plus 2. So what are we going to have here? We're going to have 6 on the top, right? You're $4 in debt. You pay back 10. We now have we have a balance of 6. You're negative, you're $8 in debt. You pay back 2, and I'm sorry, but you're still in debt. But we're going to end up with a -1 here. What if we did it the other way around? Right? What if I accidentally called this point 2 and this point 1? All right. Well, then we would do this, right? It's your choice as to which one you want to go with here. But y2 says -10, right? Minus a -4. And then x2 is -2. And then we have minus a -8. All right. So $10 in debt. Let's go deal with this. So we have -10. Negative plus a negative is a positive. All right. -2. Negative and negative is a positive. Plus 8. All right. So here you're $10 in debt. You pay back 4 of those. And I'm sorry, but you're still in debt. -2, right? You pay back 8. Now you got a balance of 6. So notice the negative sign changed where it was, but that's okay. It doesn't change the value of this answer. Okay. That's the one thing that will happen is you will get the negative sign in the opposite spot if there is one. Okay. Than if you do it the way that somebody else did it. Okay. Sometimes you might end up with a negative over a negative, which will be positive. The other person won't end up with any negatives at all. That's okay. Okay. So it doesn't matter which way you do it. It'll work either way. Oh, so -1. Let's see. I'll come back to that one. Oh, this is the one I was waiting for. Okay. So this one we may not come back to. It's fraction. It's decimals that do the same thing. Usually, students are pretty good about decimals. If you're not, you really want to see this one. We can go back to it. That's okay. But I think the fraction ones are scarier, right? And let's work on this one. All right. So what do we have here? We have 10 -3/4. This is right x1 and y1, and negative 4 and 7 over 6. And again, this is x2, y2, okay? So the same idea, right? We're going to say our slope is equal to y2 minus y1 over x2 minus x1. So one thing to do when you're dealing with a new formula, or perhaps a formula you're not so happy about, is to always write it down, okay, before we go into doing anything. So we have 7 over 6 minus a negative 3 over 4, right? x2, negative 4 minus 10, all right? So this one is going to be a little bit of a problem, okay? So we have to be able to get common denominators here, because I can't do 6s and 4s. We got to get a common denominator. And I think 6 times something would be 12, and 4 times something would be 12. So I think 12 is a good common denominator here. If you pick 24, there's nothing wrong with that. Your numbers are going to be a little inflated. So what? You can cancel when you're done. Okay, so what I'm going to do is I'm going to multiply this by 3 over 3. So we're just multiplying this by 1. That's all we're doing. And this is 2 over 2. We're just multiplying by 1. So here we have 14 twelfths minus a negative, so we need plus, right? Minus a negative. And then we have 9 twelfths. All right. And on the bottom, right, you're $4 in debt. You spend $10 more dollars. Now you're $14 in debt. All right. I'm going to go ahead and do this. Turn this into a fraction as well, because we're going to be dividing fractions. Okay. So 14 plus 9, what is that going to be? That's going to be 23. We have 23 twelfths divided. Oh, this is a delightful problem. Negative 14 over 1. So here, let me write this in a way that you may have seen before. It's scarier, if that's possible. Right, but that's effectively what we have, right? We have one fraction. That's what this sign right here means, is divided by another fraction. And if you remember the rules for fractions, right? When you have to divide a fraction, that's going to be 23 over 12 times 1 over 14. You leave that negative, right? We invert and multiply. That's how we take care of this. Unfortunately, 23 and 14 don't go into each other, so there's nothing here that's going to cancel. We're just stuck with this. Okay. Pick this problem. This one's terrible. Let's see. I don't know my 12 and 14 times tables very well. So I'm just going to go ahead and do this. All right, so we have 100 plus 20 plus 40 plus 8. Okay, so what is that going to give us? It's going to give us 168. Okay, so we have negative 23 for 168. And again, I'm sure that's delightful. Okay, I'm sure that's delightful. So again, if you're looking at this and like, there's no way. All right, you live in the 21st century. You are allowed to enjoy it at least a little bit. All right, so let's do the top. Okay, let's do this in a couple of different spots here. Okay, this says that we have 7/6, right here's my top, 7 over 6 minus, okay, a negative 3/4, right? So let's just clean that up a little bit. We'll say that's 7 over 6 plus 3/4. This will work this for you, you know. 7 divided by 6 plus 3/4. That looks like this, doesn't it? All right. I'm going to be a little bit less happy about that. I don't want to do the decimal, so I'm going to go ahead and turn it back into a fraction. But there's my 23 twelfths. That looks familiar, doesn't it? Right, there's my 23 twelfths. And at this point, right, we have 23 twelfths. We could say divided by 14. Okay, because that's what we have here. It's divided by 14. Well, negative 14, right? All right. And again, I'm not that happy with the decimal because I think the book isn't going to like that. But we can go back and hit math, fraction. There we go. Hey, look at that. All right. So if you break it up and take your time with it, do the top, divide it by whatever you got on the bottom, you're going to end up with the same thing. And again, maybe practice a little bit. But if you're getting frustrated with it and it's not working out, we have technology. Okay. So I don't want you to sit here and think I'm never going to get this. Like I get it. Fractions are tough. I remember the pain. They didn't get clear until calculus. Okay. Calculus. I was like, oh, is that all they are? Yeah, that's all they are. So you know, it's okay that if you're stuck, you're having trouble with these, like you're not alone. All right. And I also, for, you know, we have different kinds of calculuses here, but I had a student who was Calc 2 student, and I told her, I was like, you know, if you have trouble with something, let me know. I'm not going to belittle you. I'm not going to make you feel small for like not knowing something. You know, the job is to, to work on getting you through this, right? To fix the problems. And she came to my office hour one night. She's like, I gotta confess, I don't know how to do fractions. I'm like, okay, let's fix that. So in Calc 2, you know, she's having trouble with fractions, and she did really well in that class. I mean, she got her fractions sorted out. We got that fixed. She came in a couple extra times for some help with the calculus, which was, it's never the hard part. When you get to calculus, it's this that's the hard part still. The calculus isn't so bad. Okay, but all right, let me go back one. Okay, so problems like this, right? I hate graphical problems because I never really know what I'm doing with this. Okay, I got to count blocks. That's what we got to do. And I would recommend every one of these problems, you know, every one of these problems has one of these spots that will actually hit a corner. And I'd recommend finding the ones that hit the corner. And for us, right, there's your corner. Right, there's our corner. So it looks like we're going down one block. Okay, we're going down one block, so that's going to be a -1. And then we're moving over, right? 1, 2, 3, 4 blocks. So the slope of this line would be -1/4. Okay. I'll do it the same way my high school teacher did this. I did this for my pre-calc class last year. They thought it was hilarious. When my high school teacher would graph something, he decided that graphs were ducks. So we went down, and that's a quack. And then we went over 4, so that's waddle, 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 waddle. So it's 4 waddles and 1 quack. So we have 1 quack down and 4 waddles over. So -1/4. Okay. If that helps you, okay, graph and remember which way you're going with things, then that's great. If you look at that and you say, this guy is insane, I never want to do that again, that's fine too. But I remember that from like, God, 25 years ago. All right. So let's check, right? -1/4, -1/4. And you know what? I will bet that if you give it a decimal, I'll bet they'll tell you that that's just fine. Okay. Oh, write your answer without a decimal point. They're not going to tell us it's just fine. Fine, it's 1/4. All right. So next one was a special case. Okay, the next one was a special case. Determine the slope of the line. Well, it's not moving up. Okay. Remember, it's the change in y over the change in x. This one ain't changing, does 0. And then down here, I don't care. As long as there's a number, I don't care. As long as it isn't 0, I don't care. So pick a number, pick any one you want. 1. All right. A lot of times, I notice a lot of students get these mixed up. Which one is a number and which one isn't? So if we're going to guess 0, right, that would be a good guess for both of these. How do I undo the division, right? How do I undo divides? And that's multiply, right? If I was to treat this like a regular problem, we could multiply both sides by 1, right? And we'd have 0 is equal to 0 times 1. It's like, okay, that's probably the first multiplication table I ever learned. Ones or zeros. Great. I like that. I'm happy. This one, we have, again, right, times 0 times 0. We cancel. We have 1 is equal to 0 times 0. Like, wait a minute. That does not make any sense. I don't like that at all. Okay, so this is undefined, whereas this one is 0. Okay, so if you ever are looking at this, you're like, I'm confused. I don't remember which one is which. Make your guess, and then see if it follows through when you multiply both sides by the bottom and see if it works. The only one it doesn't work for, really, what if I do that? What would you think it would equal? Right? Let's put, you can put in 0, but I'm going to submit to you, I could put in anything here. Right? You say, oh, well, this works, right? 0 times 0. Like, well, what if I put in anything else, right? What if I say 0 over 0 is equal to 1, right? A thing over itself should be equal to 1, right? And then we multiply. We still get 0 equals 1 times 0. That's still true. You could put any number you want in here, and it'll always work. So 0 over 0 is what they call an indeterminate form. Whereas something over 0 is undefined. I don't think anybody will call you out if you forget that one of these is different. If you just remember if something's over 0, it's undefined, I think you'll be fine. But eventually, if you find yourself in Calc 2, you're like, oh, that's what he meant by indeterminate. You can go back and do that. But if you're not going that far, I don't think anybody's going to call you out on this. So just remember, if it's over 0, it's undefined. 0. Better not ask me for a fraction. Okay. Let's see what else we got here. All right. It's a lot of problems. All right. All right. So what we want to do here, we're going to write the equation in slope-intercept form, and then determine the slope and the y-intercept. All right. So slope-intercept form. This is like the way that everybody wants their lines written. And to be honest, you have so much practice doing it this way, it makes it the easiest way to think about it. Okay. So you always want y is equal to mx plus b. Your m is your slope, and your b is your y-intercept. Okay, you always have to remember that mathematicians are not very creative people. This is slope-intercept form, because the slope is given to you and the intercept is given to you. All right, the name is exactly what it tells you. So if we have this problem, right, we have a negative x equals negative 3y plus 3. Well, it looks like we kind of have to do some shuffling, right? We have to get the y on one side, we have to get the x on the other side, and then we have to do some other stuff. But let's worry about trying to get at least the x's and the y's in the right spot. So why don't we add 3y to both sides? Okay. Why don't we add x to both sides? So negative 3y plus 3y, that's going to be 0. That's what we want. We want to get rid of it. It's over here now. And then equals, and then is 3 plus x the same as x plus 3? We do that? Yeah, that's okay. And then the last thing to do, right, is divide everybody by 3. So we're going to divide by 3. We're going to divide by 3. All right? So 3 over 3, that just gives us y. And then here we have x plus 3 over 3. You're allowed to break this up. Okay, if it's on the top, you can break it up. If I've got 4 quarters, because I'm going to go off and do laundry, I could say I've got 1 quarter in one pocket and 3 quarters in the other pocket. I could say I've got 2 quarters in my front pocket and 2 quarters in my back pocket. That's fine. So with this, if you want to break it up and say this is x over 3, plus 3 over 3, or over 3 just means times 1/3. These mean exactly the same thing, okay? So if you do 18 over 3 or 1/3 of 18, you're going to get 6 either way. Doesn't matter. How do you want to look at it? We're going to make that 1 though. And since I'm suspecting that they're kind of going to want a slope written as a slope, we'll write it as 1/3 x plus 1. Okay, just for the sake of making that happen the way I think they want it to happen. So the slope, oh, they needed that anyway. They needed 1/3. You're at x over 3, they're going to get angry at you. That's not the slope. And the intercept, well, the intercept is when x is equal to 0, what's y equal to? So if I plug 0 in here, right, we get y is equal to 1/3 times 0 plus 1. That cancels. It's also called the slope-intercept form, so you can just read it off of here too. But if you forget, right, you always have something to go back to. All right? And then write the equation in slope-intercept form. We have y equals 1/3 x plus 1. Okay? I'm kind of, let me check. I wonder if they'll let me do it that way. Let's see if they get mad at me for that or not. Huh, they said it was okay. All right, I guess we don't have to. So it'll work for 1/3 too. That's what they wanted. Okay. Now we're going to graph this equation. All right. Now, what I would recommend is to pick x's that are going to be easy to deal with this. Like, don't pick 1. Okay. We already have 1 point. That's when x is equal to 0. We have a y. 0, 1. But if you pick 1 in here, I'm going to end up with 1 plus 1/3, which is going to be 4/3, and that's going to be a pain to graph. Why don't we pick 3? Because it'll cancel. So we'll have y is equal to 1/3 times 3 plus 1. See? So that cancels, and we just get 1 plus 1. We end up with a 2. Okay? We could pick 6. Right? 6 over 3, that's 2. All right. So you want to make your life easy and pick numbers that are going to work out for you well. So let's see here. All right, fine. I'm just going to give you that. Place a first point, 0, 1. Okay. And then we wanted 2, 6, right? No, we wanted 6 and 3, didn't we? All right. We wanted 6 and 3. Be careful not to get them backwards. And they were happy with that, so very good. All right. Let's see here. I know we're going to be working on this one tomorrow too. That's fine. Okay, that's fine. Oh, okay, well, let's take a look at this one. All right. So this one's a little tricky. Okay. Graph this one, put it in slope-intercept form. So we have 4y plus 5 is equal to 1. Again, what we want to do is we want to make it look like that. So we don't have any x's. Like, that's okay. Let's figure out what b is. Okay, we can have 0x. That's fine. Plus what? So let's go ahead and subtract 5 from both sides. So we have 4y is equal to 1 minus 5 would be negative 4, yeah? And then we have to undo 4 times y. We have to undo that time. So we're going to divide both sides by 4. So we'd end up with y is equal to, you can put the 0x minus 1, okay? I don't think they're actually going to want this. I think you're going to have to simplify this and say y is equal to negative 1. Okay, and I'm trying to get in the habit if I just have like a variable equals a number, I'm trying to get to the habit of writing out the line y equals -1, because you might have a solution to an equation that says y equals -1, and I want to distinguish between having a solution versus having a line. So in this case, right, this is kind of like the problem we did a little while ago, right? This is 12. I think we were looking at 7, right? We just had this line here. This was just slope was equal to 0. So now, right, we still have slope is equal to 0. So the slope is, let's see if it, well, let me do that, 0. The y-intercept is 0, -1. It's still written, right? It's still written in y slope-intercept form, even if it's like this, because the 0x is implied, right? So right in slope-intercept form, we have y equals -1. Right, hooray. And then they want us to graph it. Okay. We just have to go down to the point y equals -1. Well, you want 2 points. And just pick any 2 points, right? Doesn't matter what x is. Y is always -1. Okay. All right. Let's see. Okay. So in this case, they want us to categorize the kind of function that we're working on. And there's a lot more of this in college algebra. Okay. So this is actually there's a big part of the class that involves classifying these and being able to graph them without having to worry about it. And we want 3 over x minus 1. Well, remember that times and divide you can really write as a fraction, right? This is 3 times 1 over x minus 1. And you might think, well, that kind of looks like y equals mx plus b, but it's x is 1 over. Like, no, that's a non-linear. Okay, it's a nonlinear function. So when I'm looking at this, it's not constant. Constant is that, right? That's y equals a value. Y equals, let's go with b. That's constant. Y is always the same, constant. Linear means it looks like this. Anything that isn't either this shape for constant or this one for a linear is neither one or the other. Okay, we just don't have to worry about that. So it's not linear or it's constant. Okay, g of x, right? This is y equals mx plus b. Like, even though it's a fraction, like, that's okay. The x is the thing that you're looking for, right? So this one is going to be linear. Okay, y equals -1. We just dealt with that one, but that's a constant function. Okay, and again, we put the x is on the bottom of the fraction. What are you doing here? That's not a linear function. It's not a constant. It's non-linear. Right? So that's, I think I'd like to kind of stop here for the evening and let you at least get to this point with it. And we will take a look at what else is going on with the rest of these. There's a lot of lines. I have a feeling we're going to be dealing with some word problems in here somewhere. Oh, average rate of change, awesome. Oh, they have some good problems in here. All right. So yeah, we are going to, we will go back and revisit this because there's a little bit more going on here that I would want to do in one day. Okay. So I'm going to stop here and stop recording.